This is CPM Precalculus, Chapter 2, number 62. So if the rational expressions have a common factor, it is usually easier to add the terms using the standard method of first finding a common denominator. Okay, common denominator is the key thing. So first find the sums of the following. Okay, and first find equivalent fractions as shown in the example below. So let's go ahead and look at the example first. Okay, so here's the example. We have 5 over x squared minus 4 minus 2 over x squared minus 6 minus x. Minus x minus 6, excuse me. Okay, so first what you have to notice is, looking at this alone, you see that x squared minus 4, okay, is the difference of two squares, right? So that is equal to, when you go ahead and factor it, it's going to be, well, this is, before I say what it's equal to, let's go ahead and see that this is equal to x squared minus 2 squared, right? And so that's the difference of two squares, which is x plus 2 times x minus 2, right? You add and subtract the two terms that are being squared, all right? So this, and also, what do you see here in this denominator? Well, you can go ahead and use the x rule, right? I think this is what you call it. What numbers do you multiply to get negative 6, right? And add to get negative 1. So what numbers do you multiply to get negative 6? Well, you can multiply negative 3 and positive 2, right? These numbers multiply to get negative 6 and add to get negative 1. Okay, so then I can say from this that x squared minus x minus 6 is equal to, when we factor it, x minus 3 from here times x plus 2 from here. Okay? So this is just a side note. I'm going to put it in a little cloud or a bubble, right? So I can say that in this example, 5 over x squared minus 4 is equal to 5 over x plus 2 times x minus 2, right? And I'm just pulling that from here, minus 2 over, and then I can say this is equivalent to this. So I can write, instead of x squared minus x minus 6, x minus 3 times x plus 2, right? So the shortcut is to find equivalent fractions, we want to find a common denominator, right? Well, what we can notice is that the common denominator is just going to require us to do what to each denominator, right? We only have to multiply by the missing piece, okay? So they both have an x plus 2, right? So that means we can just multiply by the x minus 2 over here, over x minus 2. And let's put them in parentheses. And over here, we can multiply by x minus 3, over x minus 3, right? Put that in parentheses. All right. So then what we have, let me go ahead and go back to blue. We have 5 in the numerator times x minus 3 over x plus 2 times x minus 2 times x minus 3, right? I'm just copying this now. Minus 2 times x minus 2 over, in the denominator we have, let me go ahead and put these in the same order as we see here, right? So I'm going to pull out the x plus 2 times the x minus 2 times the x minus 3, right, from here. All right. So from there, we have a common denominator, right? They both have the same denominator, so I can go ahead and add or subtract the numerator. So I have 5 times x minus 3 minus 2 times x minus 2, all over x plus 2 times x minus 2 times x minus 3, right? Now, in the numerator, I can go ahead and distribute the 5 here and make this a positive and negative 2, so I can distribute the negative 2 and go ahead and combine like terms in the numerator. So I have 5x minus 15 plus negative 2x negative 2 times negative 2 is positive 4, right? In the denominator, I still have x plus 2 times x minus 2 times x minus 3. Combine the terms in the numerator. I have 5x minus 2x is 3x. Negative 15 plus 4 is minus 11 over. In the denominator, I have x plus 2 times x minus 2 times x plus x minus 3. All right. So this right here is the simplified version when we're adding the two rational expressions. Okay. So the process we did was we looked at the factors, right? We factored this, and then we found what we needed to multiply to make them have a common denominator. Okay? So let's go ahead and look at the two problems. We have A here and B here. So let's start off by rewriting A and A with, let's factor the denominators. Okay, so you have 2x minus 5. What are the factors of 6? 2 times 3, right? Plus x plus 1. What are the factors of 8? Well, 8 is 2 times 4, but 4 can be factored as 2 times 2. So this is 2 times 2 times 2, right? So in the left, then, we're going to have to multiply. Well, we have a 2 and a 2 that match. So we have to multiply by the extra 2. So let's go ahead and just call that 4 over 4, right? And over here, we're going to need to multiply by 3 over 3, right? Because we have a 2, right? And we just multiply by the 4. So we need a 3 over 3. Okay, so that's going to give us a common denominator now of 2 times 3 times 4, right? Or 2 times 2 times 2 times 3. 2 times 3 is 6. 6 times 4 is 24, right? 2 times 2 is 4, times 2 is 8, times 3 is 24, so we have 24 in the denominator. In the numerator over here we have, well, make sure these are in parentheses, we have 4. Now let's distribute the 4, so we have 8x minus 20 plus, distribute the 3, 3x plus 3. Combine like terms, we have 8x plus 3x is 11x minus 17, negative 20 plus 3, all over 24. Okay? So that's how we went ahead and simplified this expression. Alright, you'll notice that it's simplified, right? Let's go on to part B. Part B, again, we want to do the same thing. We want to go ahead and factor the denominators. So let's rewrite this, right? This is equal to x over, and let's go ahead and factor this. So let's use the x method again. What two numbers multiply to get negative 8 and add to get 2, right? So we know 2 times 4 is negative 8. So if we multiply 4 and negative 2, right, it will multiply to get negative 8 and add to get 2. So that's telling us that if we have x squared plus 2x minus 8, we can factor it as x plus 4 times x minus 2. Okay? So then here, let's put this in a little bubble because it's just the side work. So here we have x plus 4 times x minus 2, right? We're just pulling out and factoring the denominator. Plus, and I'm going to rewrite this as 2 over x plus 4. Now we see what is the common part in the denominator. Well, they both have an x plus 4. So if we multiply just this one by x minus 2 over x minus 2, we're going to have a common denominator. Okay? So the common denominator is going to be x plus 4 times x minus 2. In the numerator, we have x here. Oops. Right? X plus, distribute the 2, 2x minus 4. Let's go ahead and combine like terms. So we have 3x minus 4 in the numerator over x plus 4 times x minus 2. Okay? And when we're simplifying, let's go ahead and keep the factored terms in the denominator like this. Okay? And go ahead and start doing that. And you can go ahead and do that in the numerator too if there were any if we were able to factor this. Alright, this ends CPM Precalculus Chapter 2, number 62.